This is mole calculations in under 5 minutes. Moles are a measure for the amount of a substance and is defined as the amount of substance that contains the same number of particles as Avogadro's constant, where Avogadro's constant is 6.023 times 10 to the 23. So if you had 1 mole of CO2 gas, that would mean you have 6.023 times 10 to the 23 particles, or molecules, because it's a simple molecular substance. To find the number of atoms in 1 mole of CO2, you would times Avogadro's constant by 2, as there are 2 atoms in every CO2 molecules, and that gives an answer of 1.2 times 10 to the 24 atoms. There are 3 equations for moles that you need to be aware of. The first is for calculations with masses, which is moles is equal to mass over mR. The second is for calculations with gases, which is moles is equal to volume over 24 dm cubed. We use 24 dm cubed as it's a molar volume of gas, which means 1 mole of any gas at room temperature and pressure always takes up 24 decimeters cubed of volume. A lot of questions will give volumes in centimeters cubed, so you need to be able to convert centimeters cubed to dm cubed. To do that, you divide by 1000, and for the other way around, you times by 1000. The third equation is mostly used for calculations with titrations, where moles is equal to concentration times volume, where concentration is measured in moles per dm cubed, volume in dm cubed, and moles measured in moles. When carrying out mole calculations, there are 3 basic steps that need to be taken. The first is to find the moles of the known substance using the correct formula. The known substance is what you know the value of. The second step is to use the ratios from the balanced equation to find the moles of the unknown substance, which is the substance you're trying to find out. And the third step is to find out the unknown value by using the correct formula out of the 3. For example, if we wanted to work out the mass of potassium oxide that was produced from 23.5 grams of potassium, we can label what's known and unknown on the balanced equation. We know the mass of potassium, so we can label that as known, and we're trying to find out the mass of potassium oxide, so we can label that as unknown. So the first step is to find the moles of the known substance by using the correct formula out of the 3. As we're dealing with masses, we can use the first equation, moles is equal to mass over mR. So that means it's 23.5 divided by the mR of potassium, which is 39.1 according to the periodic table. This gives an answer of 0.601 moles of potassium. Now for the second step, we need to use the ratio in the balanced equation to find the moles of the unknown substance. So our ratio is 4 to 2, as that's the numbers in front of them in the balanced equation. That can be simplified as 2 to 1. So for 0.601 moles of potassium, we can divide it by 2 to find the moles of potassium oxide. This gives an answer of 0.3005 moles of potassium oxide. For our final step, we can use the moles of the unknown substance to work out what the unknown substance is, which in this case is mass. So we need to use the first equation again, which is mass is equal to moles times mR when rearranged. So we can do 0.3005 times by the mR of potassium oxide, which gives 28.3 grams. If part B of the question asks for the volume of gas required for this reaction, that would be oxygen. So our known would be potassium and our unknown would be oxygen. Our first step would be the same, as we're still dealing with masses as we're given the mass, so that would give us 0.601 moles of potassium again. This time the ratio is 4 to 1, as O2 has a 1 in front of it, so we divide 0.601 by 4 to give us 0.15 moles. This time, for step 3, we would use the second equation as we're trying to find out the volume of a gas. So if we rearrange that, we get volume is equal to moles times 24 dm cubed. So that's 0.15 times 24 dm cubed, which gives 3.606 dm cubed. In this titration example, we have a known concentration for HCl, but we're trying to find out the concentration of NaOH. So our first step is to find out the moles of HCl are known. So this time we'd use moles equals concentration times volume, as we're dealing with the concentration and volume. As our volume is given in centimeters cubed, we need to convert it into dm cubed by dividing by 1000. This gives a value of 0.025 moles of HCl. For our second step, NaOH and HCl both have no numbers in front of it in the balanced equation, so the ratio is 1 to 1. So that means if you have 0.025 moles of HCl, you also have 0.025 of NaOH. And for our third step, we're trying to find out concentration, so we would use the third formula. So that's moles equals concentration times volume, or if you rearrange, concentration equals moles over volume. This is 0.025 divided by 28.7 over 1000, because we're converting into dm cubed, which gives us a final answer of 0.87 moles per dm cubed. Another formula you might be asked to use is PV equals nRT, where P is pressure in pascals, V is volume in meters cubed, N is the number of moles in moles, R is the ideal gas constant, which is 8.31, and T is temperature in Kelvin. For this question, you need to start off with the conversions. So you're given 100 kilopascals, so you need to times that by 1000 to find it in pascals. Next, you need to convert 100 centimeters cubed into meters cubed, and to do that, you need to divide by 100 cubed, and that gives you 1 times 10 to the minus 4 meters cubed. For temperature, to convert from degrees C to Kelvin, you need to add 273, which gives 293 Kelvin. Now you have all of these values, you can put it into the equation by rearranging it. N is equal to PV over RT, and subbing all of these values in gives you an answer of 0.00411 moles. This was obviously a very quick summary. For a longer, more detailed explanation of the topic, check out the link to the full lesson and subscribe to my channel.